In this video we have the integral of 16 over the square root of 16 minus x squared. Looks like it fits a trig substitution. Let's look at the forms. For integrals involving the radical of the square root of a squared minus u squared, you can use this substitution, u equal to a sine of theta. Now if this is already x here, say x squared, then the u would be the x throughout here. And we're transforming it into an integral involving the variable theta. And then you have the other two main forms that you can have involving tangent or secant. So in this case, I'm going to let x equal to, instead of u squared here, this is x squared, that's okay. And then the a squared, the constant, this would be, say, 4 squared. The a would be 4. So this would have the form then x is equal to 4 sine of theta. So dx would be 4, derivative of sine is cosine. This would be d theta. Now if we make the substitution in this radical here, so we got the square root of 16 minus x squared, but the x is 4 sine theta, so this would be 16 then. And if I square the x here, I get 16 sine squared theta. Factor out the 16 here, and then square root would give me a 4. And then this would be 1 minus sine squared theta. 1 minus sine squared theta under the radical can be written as cosine squared theta using one of your fundamental identities. But then we're taking the square root of that, so this would be cosine. So now we come back over here and convert the integral here. This will be 16, and then the dx right here would be 4 cosine theta d theta. And then this radical here comes out to 4 cosine theta. 4's cancel out here, cosine and cosine cancel out. So all we're left with then is 16. That is the integral of 16 d theta. So we integrate with respect to theta here, and we get 16 theta plus the constant of integration. And remember from here, the initial substitution, we know that sine of theta is equal to x over 4. So we generate a right triangle here. Call this angle theta. So notice here we're using acute angles here for this triangle, so that's why we take the absolute value or the square root of cosine squared. Because the angle is acute, we don't need absolute values. And we know that sine is equal to the opposite over the hypotenuse, so in this case this would be 4. And this side then would be 16 minus x squared. Now sometimes you really use this triangle to simplify your final answer over here. We don't want to leave it in terms of theta, but this one's fairly easy because from right here, all we want is the value of theta in terms of x. So from this setup there, taking the sine inverse of both sides, sine inverse of this side gives me theta, sine inverse of this right side is sine inverse of x over 4. I could call that arcsine. We get that. So for the final answer then, all we have to do here then is just be 16 times the sine inverse. I could use, like I said, arc sine And this is going to be x over 4. Plus the constant of integration. Final answer then, 16 arcsine, or sine inverse of x over 4 plus the constant of integration. Thanks for watching. We'll see you next time.